Let's take a look at the idea of doing double integrals over general regions rather than restricting ourselves to simply a rectangle. What happens if we have other shaped regions? Now, when we're working with double integrals over general regions, there are two primary types of regions that we're going to be dealing with. That's really kind of a lie in that there's other types of regions, but really the other type of regions that we will work with are made up of these two types of regions, so it's not that big of a deal. Okay, the first one is called a type 1 region, and a type 1 region is bound by, or rather on the left and right, by vertical lines, x equals a and x equals b, and it's bounded above and below by continuous curves, y equals g2 of x and y equals g1 of x, where g1 is less than g2. So in other words, if I draw this thing out, it's going to look something like this. On the x-axis here, I'm going to have a to b, and above it I'm going to have this curve, which I'm going to call g2, and below it, say g1. So it's bound above and below by these two curves and the vertical lines x equals a and x equals b. So in here is my region R, or we very commonly refer to it as D. So R or D is kind of a common notation to use for either of those regions. And now the second region is, you probably guessed it, a type 2 region. And a type 2 region is bounded below and above by horizontal lines y equals c and y equals d, and on the left and right by the continuous curves x equals h1 of y and x equals h2 of y for c less than or equal to y less than or equal to d. So if we draw that out, rather than the x-axis having vertical lines, I have horizontal lines on the y-axis, and then I'm going to have some curve over here, some other curve over here. Here's my vertical lines, and I'm calling this one h2 of y, and this one h1 of y. And of course, that's kind of an ugly arrow. And of course, this is my region that I'm talking about. Now, this idea, or these two regions, leads to a nice theorem that actually tells us how to have integrals, or how to evaluate integrals if we have regions of this type. So, if we have a type 1 region, and of course our surface f of x, y, z, this is, or f of x, y, that's what we're thinking of as being z, it's our surface, is continuous, then the integral of the surface over this particular region is equal to the integral from a to b, then the integral g1, g2, f of x, y, dy, dx. So I'm going to integrate first with respect to y of g1 to g1 to g2. So let's jump up here and see what that looks like. With respect to y, g1 to g2. I have put this as a gx. This should be a g2. There you go. And then once I've integrated in this direction in reference to y, next I'm going to integrate in this direction in reference to x. And that's exactly what this is telling us to do right here. First with respect to y, and then second with respect to x from a to b. Then obviously we're going to do just the opposite if we have a type 2 region. So first I'm going to integrate in here with respect to x. That's where my curves are. With respect to x, here's x and y. So I'm going to integrate in this direction initially. And then when I'm done in that direction, then I'm going to integrate in the direction of y, which is exactly what that is telling us to do.